Okay, so I will take your paper copies later. Okay, I'm gonna get started now and then just get them from you later. Okay, I will tell you where we're going. Okay, where are we going from here, and why it is important to really master this. Uh, for like today, you will be given an equation. Every time there's a word problem, there'll be an equation associated with that word problem. That is about to change, where you're not going to be given an equation. You will have to come up with it, which is very doable. Like the calculator does that for you, so you don't have to panic on that. But so this is like the very basic. So if the equation is given, you plug that in and you can answer anything the question throws at you. You just have to know which options from the second trace from the calculate, right? Like which one of these am I going to use to find that information, right? And so essentially nothing changes from a non-contextual, right? But now we're doing, everything is going to be surrounded by a text, right? So things change. Your domain and range will change. It's not going to be infinity anymore, okay? Things like that you have to watch out for. It's going to be most likely 80% of the time in quadrant 1, sometimes in quadrant 4, which is right below quadrant 1, because something is going below ground, like a submarine or a bird or something like this, right? Bird diving for fish or something like that, you will see that it goes underground, okay? So when you're given an equation, you want to type that into Y1 right away, okay? And I will show you what this is supposed to look like, okay? So when you type that in, if you want to follow me, oops, and this is going to be a straight line, right? You saw that? I made a mistake. I saw it just before I hit graph because I forgot the x squared. Okay, so I needed to adjust my window a little bit. Still not going to be good enough. There it is. So in this case, this is one of the cases where your vertex is also your y-intercept, right? And it goes straight down from there. And it's because of the context, right? The herd comes running here, and then at some point by the cliff, they just fall down. So the action starts right here, right? At the highest point. Right? So a little different than the examples I gave you, right? But that is to be expected. So I make some notes here, and I will go over the second question in more detail, right? So now I'm just walking you through there, right? I'm saying that the vertex is also the y-intercept. Based on this equation, the x value is my time, and the y value, which is on the left of the equation, every time is the height, right? And we're talking in feet and seconds again, right? And so the first thing is graph this situation, consider the scale, labels, and shape. So to graph, I always want my vertex and the intercepts. Those are important to me. I don't care about this intercept, right? I hope you understand that, right? This one I don't care about because it's in the negative domain, right? I can't use that. So I'm using the vertex and the X-intercept, and that helps me set up a scale, right? I just happen to go up by 1 here. I made every fourth box, right, be one full unit. And so that was my, so 0 here technically, right, that's assumed, right? You're starting right here, and then you go up there. So you should not be going past. If you did that, erase it or tell yourself that that's not supposed to be there, because you will lose. You're basically going against your domain and range if you do that. Okay, so I start with my y-intercept, which is also the vertex. I have my equation. The points are where they're supposed to be. I have time and height labeled beautiful graph, right? I'm talking about your graph right now. You have a beautiful graph by now. Okay, how long are the buffalo above ground, right? So obviously it starts here with time 0 and until you hit the ground. So it's 2.56 seconds. I'm going through the whole motions again here, right? So sometimes you'll find that you can just borrow from what you've already done, but I'm going back and doing everything again. Okay, what's the initial height? That's my y-intercept, and that is 0.32. So the 32 is my initial height here. At time 0, you're at 32 feet. This is saying at time 2.56, you're going to be on the ground, right? So the pairs always tell you a story, right? And then D, it says how long are the buffalo at or above, so sorry, back up here, at or above 15 feet. So this is one, it's like, wait a minute, didn't Mr. Dirksen, you go back in my example, you're like at or above, how come I'm not subtracting anything here, right? Well, because like anything back here where the curve comes back down, like that point on the left here, that we do not consider it. You have to start here until, right, here. So it's this time here, during this time that the buffalo were at or above 15 feet, right? So all you do there is, right, what's the x value when y is 15? You graph that, and it's 1.86 seconds. Okay, and we will say, maybe what I will do here is for your notes, I will quickly find the other one so you know. Negative, right? Omit negative 1.8615. Okay, this is a negative one. We do not consider it there. So this is one of the cases where you don't have to subtract by another point. Then our domain is just from time 0 till they hit the ground, and I got that from my x-intercept. And the range is 0 to 32. Make sure you put the 0 first, then 32, and I got that from the vertex. Okay. And now I'm going to do the second question on page 7, which I will go through step by step. Okay, this one I thought was doable. So let's go to page 7 here. In a football team, a team can score by kicking the ball over the bar between the two uprights. The crossbar is 8 feet above ground. It's probably an important piece of information, right? A path of a particular kick can be modeled by, there's my equation, where h is the height, right? H is the height in feet, d is the horizontal distance in yards. So they're mixing up feet and yards here, folks, right? So d is the distance. So that means that every point when I graph this thing, right, the first one is going to be distance in yards, and the second point is going to be the height in feet. All right, so it's basically still your x and y when it comes to the calculator, right? It still sees that as x and y, but we need to make sure we define our variables. And I want to make note of another thing. If you come over here, you can tell that, right, this is ax squared plus bx plus c. That's normally what a quadratic looks like. So you have the ax squared, right? You have the bx here, but there's no c apparently, but it's really 0. That means that this action is starting right on the ground, right? your initial height is going to be on the ground. So you just got to keep that in mind. Okay, c is equal to 0, starts on the ground. Okay, graph the path of the ball. I will do this with you here, so just follow me or watch. If you've done the work, you're doing good. Plus 4.1x, right? You type that in, and I'm already going to do this. Go ahead and graph it, and it starts right at the origin on the ground because my y-intercept is 0, 0 according to this, right? Because it's always 0c, so it's 0, 0. I'm just going to change my window. I think I'm going to go 50 for x max, and there it is. So I'm going to find the intercepts. I'm going to find this one first, which I know already is 0, 0, but I'm just making sure, and it is 0, 0. So for the graph here, x-intercepts would be 0, 0. I'm going to find a second one. That is 34.17. 0. My y-intercept is 0c, which turns out to be 0, 0. So x-intercept and y-intercept are shared, right? They're the same thing here. The vertex, you don't need to show your keystrokes when you're trying to graph, okay? Because you're going to need to do this anyways. So I'm going to find the maximum here. I'm going to go to the left of the vertex, to the right of it, and that's 17.08, and this is 35.02. So this is all I need to graph. Okay. So I'm going to say distance in yards, and I'm going to put down height in feet. Right, I have that. And for my x-intercept, I need to make sure I have enough for 34 to fit in. So I'm going to go up by 10. I have a pretty good feeling about that. Okay. And my vertex, go by the vertex, goes all the way to 35 as well. So I'm going to go up by 10 also there. And just so you know, I always freehand it. So my answer key might be a little different than this, my graph, okay? I don't really go off my answer key, I just have it here in case. Okay, so 0, 0 goes there, 34.17, this would be 35, so I would like it to be just under 35, and then it's 35.02 up here, 1708, so this would be 15, this would be 17 and something, and I'm going to go all the way up to 35, which is right about there. Okay, and then you go out sideways a bit and then curve down. Out sideways and then curve down. There you go. And that would be a full graph, everything on there. Don't need to label. That's it. I used to be, some of my keys will have that, but in grade 12 on the exam, as long as it's where it's supposed to be, you're fine. How far from the player does the ball land, right? So if the player kicks it here, right, obviously we're asking for the x-intercept here. Find the x-intercept. So y2 is equal to 0, second trace 5, right? And I'm going to borrow from here and just take that number. I'm going to trust it, right? So 34.17, what is it? We're in yards, right? The horizontal distance is in yards. Yards, that's it, from the player. Okay. C, what's the maximum height of the ball? I'm glad you asked because I know the answer, right? Second trace 4, right, for max, and that is 1708. I know this is a little repetitive, but on a question you will not always be graphing, right? And so this is important for you to still show your work here. And maximum height is 35.02 yards, no feet, right? Because the second number represents the height, which is in feet, right? So I purposely threw in yards and feet to make sure you understand that. Okay, so there's the answer, there's the answer. D. If the goal is 30 yards away from the kickoff point, this one is tricky. How far above or below the crossbar is the ball? So this one is a tricky question, okay? So they're saying, and I'm going to use my graph to show this, okay? This is where it kicks, right? And if the goal is 30 yards away, so let's say it's right about here. So let's graph our net. We don't know if the ball is going to be like coming over above it or below it. We don't know, right? So we have to use our calculator to find the height of our ball at 30 yards away from the initial point. Does that make sense? Right? So I know what the x value is of the ball. It's supposed to be 30 yards, but now I need to find the y value, the height. So what I'm going to do is I'm going to say, I know, right, that x is supposed to be 30 yards, okay? Determine the height of the ball at that distance. Okay, so I'm going to go second trace value, or you can put 1, and I'm going to say x is equal to 30, and I will expect a y value in return. Okay, I'll show you 2 ways of doing this. So second trace 1, x is equal to 30, and I am at 15, right? The height of the ball at that point, because remember, this is the path of the ball, is at 15 feet. All right, so how do we know if you're above or below the goal or the crossbar? How do we know that? Yeah. The crossbar is 8 feet high. So my crossbar should have probably come up to here, right? Now it looks like a hydro pole or something, right? But it should have come up to here, 8 feet, because we were told, right? It's 8 feet. So just by the graph, we could have already told that the ball is going to be above it, right? So crossbar is 8 feet tall, right? Therefore, ball is, just go somewhere on the side here, 15 minus 8, right? And that is 7 feet above crossbar. If you don't know much about football, you're going to be like, I don't get this, right? Well, it's watch some football. That's all I'm saying. I think it's basic enough to understand, right? E, the dreaded domain and range. Okay. State the domain and range. That's E. I'm reading it. If the horizontal distance is restricted to where the goal is. So they're basically telling you that this story will end, right, with the goal post right here, the horizontal distance. So that means that my domain, right, is going to go from 0 to 30. That's it. Stops where the goal is. But Mr. Dirksen, you always told us this is the X-Intercept. It depends on the question, right? So not always. And then the range is going to be from 0, right? Because it starts at 0 here. That's the lowest it ever gets. And the highest it ever gets is your vertex, is the y value of the vertex. So that's 35.02. F. I really enjoy asking questions like F, just so you know. I'm going to read it. State an equation that would model a kick with a lower maximum height. Answers will vary. Okay, so that's where I need you to come up with an example. Just give me an example, one that would work. There's many. And if you're not sure how to do this, remember that, right? Recall that A in the equation, right, changes the width of parabola. And something happens to everything on that parabola. Okay? So I'm going to ask you to always resort to your calculator to help you with it. So what I'm going to do is I'm going to go to y equals. I'm going to clear whatever's in there. And I'm going to try to go with what I already have, but I'm going to put in a different a value. So let's say you go negative point, let's say you go 0.06. Let's split this in half. X squared plus 4.1x. I leave everything else as is. Don't write it down yet, okay? Just graph it. Graph them both simultaneously. So that's the first one. And then this one, oh, what happened there? So I have to change my window a little bit. I think 150 for X max and maybe go 150 for Y max as well. So if you were to make this smaller, so original is this. That's the original. I'm going to say the new one that they're asking me for, I'm going to start the same way, but I'm going to change this. So obviously, if you make this smaller, it doesn't do the trick, right? It actually makes a wider curve, right? It makes a wider curve. So I'm going to go ahead and say, well, What if I double it? What if I go 0.24? Like I make it bigger, I make a bigger, and then graph. There it is, right? That second one, that one has a lower height than the original, right? So negative 0.24 d squared plus 4.1 d. Increasing a, increase a, right? Narrower and shallower curve. And if you're not sure, just use your calculator to help you out. But don't change anything else. Just look at, and this could have been negative 0.20. This could have been negative 0.15. Anything that's bigger than this would result in a parabola that's lower, that has a lower vertex than before. Okay? Is that it? Yeah, that's it. Phew. So what I'm going to do is the following, okay? So pay close attention to my plan. If you didn't get to the rest of the questions, like on page 7, is it 8, 9? I think it's 8, 9. Do them, because I can see that you were stuck a little bit, right? And you needed to, wait, how did you, it tells you in the question way up there, oh, way up there, right? Here, way up there, that the crossbar is 8 feet above ground. Okay, I'm gonna go back down because I'm sure somebody's still copying this and just there. Do keep going 8 and 9. I will post the detailed answer key, okay, of all 4. And if you're done already, like let's say you're like, I'm done. I'm thinking. I don't want to overwhelm you. This is what I'm going to say. Just leave it at that. Let's just do these 4. I'll keep the homework here on my sticky note. Just make sure you go back to these 4. Check the answer key. Double, triple check everything. Okay? Make sure you understand that. Because tomorrow I could ask for an AC that looks very much like this. Okay? So that is it for today.